Good afternoon, parents and students. More students now than parents because your students will not have seen this class like they normally do. So many a times when I make my YouTube videos for Mrs. P's Math Mania, it's addressed or connected to the parents so that you can see what we're doing in class. But this time, and as we progress forward, it's for your students because we're doing homeschooling. And I want you to know a couple things. This is probably like the 9th time I've tried to record this. The sunlight, the angles, my puppies running around, barking at the delivery men. And so, but we're all trying to do what we can do. And that leads me to my next point before I get started with equations. Is the other day I met with your students on Zoom or on our online chat that we're going to be doing Mondays and Wednesdays at 9 a.m. And right now they know that we're supposed to be working on review items, but in that discussion that I had with them the other day, the students, maybe with a little bit of my questioning, collectively we decided that we thought we needed to move on. We need to keep learning some new concepts. Your students are now out of school for an indefinite amount of time, and I honestly have no doubt that at some point we're going to get back together and there's going to be hugs and handshakes and fist bumps, but I don't know when that's going to happen. So in the meantime, I feel it is important that we keep learning new mathematical knowledge, and discussing that with your students on Zoom. They agreed, right, kiddos? And so that's what this video is going to be about. When we do have Zooms on Mondays and Wednesdays, I will review things. But when I make, whoa, good catch. When I do my YouTube videos, I will go ahead and discuss some new concepts with them. And this one that I'm getting ready to do today really isn't technically new, because if your student wasn't in school on March the 17th, the day before we left for our closure, we started to discuss this concept known as equations. And again, you'll have to forgive me because I'm writing right to left, and everyone knows I'm used to writing left to right. And so we started this new concept of equations, and hopefully you can see this. I tell the students more about us having the discussion than it is maybe so much of what you see me writing. But we started equations, which in their Go Math books, which everyone has at home, is located in lessons 8.1 and 8.2. And those go from, I believe, page 421 to 431. I know that seems like a lot, 10 pages, but they're going to practice their skills. They're going to practice those skills on page 425 and 431. And parents, you already know this, and the kids know this as well because I sent this information home in an email already. But they're going to practice those skills of equations using their Go Math book, page 421 to 431. Practice the skills on page 425 and 431. Evens only. I only have them do evens only. And they will practice those after we do this little lesson for 8.1 and 8.2. So when we started discussing this the other day, our first notion was we had to define for ourselves what is the difference between an equation and the concept we just left, which were expressions? What is the difference between those? And most people know that I love using the same expression all the time because I think it makes the kids think about how long they've really been doing this. Since 5, 6, since they entered school at West Platte, they have been working on expressions and equations. Hopefully you can see that. And so the one that I always use a lot is 7 plus 3. Probably more so because it's a base 10, and base 10 just helps us mathematically. So 7 plus 3 is an expression. And why we call it an expression is because it's known as a mathematical phrase. Now, some people will say, oh, so it's a mathematical statement. And just for me, Mrs. P, and that's the only person I can talk for, I don't call this a mathematical statement just for the simple fact that mathematical statements are complete, like a grammatical statement. If I'm going to make a statement, it's a complete sentence. And in this case, 7 plus 3 is not a complete mathematical statement. It's part of a statement known as a phrase. Or in this case, your kids would probably say, oh, that's the problem. So 7 plus 3 is your problem or your mathematical phrase. And to make that from an expression to an equation, your students know it's missing a component, a mathematical component, known as the equal sign, the symbol known as the equal sign. And so when we discussed this, we talked about equations and having a root word of equal in it, which then would help us connect it to an equal sign. So if I want to make this an equation from that mathematical phrase of an expression to an equation, I will need an equal sign, and I will need to complete my statement. I can put a period behind there. I can complete my statement by solving it. And so in this case, if I do it numerically, I just say 7 plus 3 is 10. And that's great for first and second graders. But your student is now a sixth grader. And so what we're going to be working on, and what we have been working on with even expressions, is changing these things so that they are now including algebra. And instead of just having numerical expressions, we're going to have algebraic expressions as well. Trying to avoid the light, but it doesn't seem like I'm going to be able to. Then you got to see my messy refrigerator. So we want to change them into algebraic expressions instead, and algebraic equations, because now this is what your students will be engaging in as they make their way through the rest of the sixth grade and on to junior high and high school. So I'm going to erase this a little bit. If you need to go back and look at these pages, by all means, you can go back and see that through the video by just going back and replaying the video. So I'm going to just go through some concepts with them about equations today. I do want them to practice their skills in lesson 8.1 and 8.2. It is on page 425 and 431, and the kids know they only have to do the evens. But we do want to discuss how we go about solving these things, because we know algebra is the process of having something unknown to us mathematically. And I always relate that to the students just in life. There's always something that's unknown. A famous one I use all the time on YouTube is, I got 20 bucks. I need to fill my car with gas. Gas is right now, what, $1.69 a gallon? How much of that can I fill up with in my car? Gasoline, that is. How much of that can I do? And that's an unknown. That's mathematically unknown. But anything that's really unknown to you, it could be considered algebraic. I need to solve for something that's missing in my life. And so there's only a few ways we can do that mathematically that will make it possible for us to find solutions. So when we took 7 plus 3 as an expression, and then we turned it into 7 plus 3 equals 10 into a numerical equation, numerical expression, numerical equation. Those are very simple and easy for us if we have really good number sense, which I want the kids to continue working on while they are home, adding, subtracting, multiplying, dividing. Every day, 10, 15 minutes, be practicing those number skills. It is vital for them as they move on in mathematics. And so we are now looking at, since we know this is a rather easy process for us, even if I did this, it's an easy process for the kids to know that 7 plus something equals 10. And that's a 5 or a 6-year-old process. That's a 5 or 6-year-old concept that they've worked on all their lives. So we're now going to actually switch it so that they're not just looking at it like it's numerical and I need to find that that's 3 and I'm going to use my fingers. We need them to find a way to solve that through a mathematical process known as an algebraic equation that will let them come up with a solution, whether they are adding, subtracting, multiplying, or dividing these equations. And so to do that, we're going to run through just a few examples, and then I want them to practice this at home for themselves. And they can do this by just looking at their math book. We have problems on there. One of the first ones on page 425 that we talked about, we went through the other day, states x, and it says x minus 7 plus 15. I'm just going to do something even more simplistic than that. If I said x plus 7 equals 15, Now, it's easy for your students to see this, and with good number sense, they're going to say it's 8. They're going to say x is equal to 8. But what I now need them to do is, it's not going to be that simple all the time. And so, of course, if they have good number sense, x plus 7 equals 15, they're going to know very easy. But we're going to start instilling more difficult problems and a difficult process that they have to go through. It's really not more difficult. They can do it because it's using basic operations in mathematics of addition, subtraction, and multiplication. But it's not normally the first thing they think of. They want something that happens just automatically for them because they're like, oh, I got good number sense, and that's great, and we do need that even to solve these problems. But you are going to have to do some work. You are going to have to do some work to actually solve these. So what I'm going to be showing them and instilling in them in these 2 lessons, which we're combining as one, because one is about solving equations and one is about writing them out, which you can do at the same time. If you can solve it, you should be able to write it in words. If you can write it in words, you should be able to write it as an algebraic equation and then solve it. So I'm going to start with the writing process, and then I'm going to show you how they are going to need to learn the concept of solving this through mathematical skills. So to write this out, the students first need to see, well, what is it that I did? Well, that equal sign that we talked about just a little bit ago is our key. So if I have an equal sign, it's telling me something, and it's telling me that the solution to this problem is 15. Well, I need to ask myself, well, what kind of solution did I solve here? And since we see this mathematical symbol, operation symbol, we know that what I solved was a solution known as the sum. Why? Because sums are answers to our addition problems. So if I want to write this in words, I'm first going to start off by saying the sum, and then I just look to see what I used in my mathematical phrase that gave me a statement. And in my phrase, I used the sum of x and 7 because it says x plus 7 equals something. So I'm going to write that in word form as the sum of x and 7. And this lovely thing has a name. It has a piece of terminology, a word that goes with it that tells us and relates it to an equation. Root word being equal. Equal sign is saying that something is the same as something on the other side of that equal sign. So here's how we write it out in words. The sum of x and 7 is 15. Now the big part that we move on from there is, how do I solve this? Not just by counting on my fingers, which you can do. It's a great strategy. Using a number line, it's a great strategy. Students have that access to do that. But we want to start having students use cognitive thinking skills that allow them, because they have good number sense, to not have to use those devices. Because they won't always be relevant, or not necessarily, they won't always be prevalent. They won't always be accessible to them. They're not always going to have that. They'll always have their fingers, of course, we hope. But they won't always have access to a number line or a number chart or a calculator. So we need good critical thinking skills. And I would prefer them not using their fingers. I want them to cognitively see this mentally in their head. And then sometimes they have to work out a process. So I'm going to go back to that problem, and I'm going to erase this again. I'm going to go back to that beginning problem of x plus 7 equals 15. And I know this video is getting long, and I'm sorry. I'm working on it. But x plus 7 was that original problem that stated that it was equivalent to 15. And so, yes, kids are going to see that x plus 7, trying to get this turned a little bit, x plus 7 equals 15. And they're going to know that 8 plus 7 equals 15. But I need them to use a mathematical process that allows them to solve these algebraic equations. And the first thing that we're always trying to do in algebra is solve what's missing. And in this case, what's missing is that x. So in the end, I want to say x is equal to something. I need to know what x was in this problem, in this mathematical phrase. What was x? What did I use to get me to that mathematical statement, that mathematical or algebraic equation? And so there is a process that we have to do using our math operations. And your students know that if I add something and I want to check myself, I can use subtraction. If I'm multiplying something and I want to check myself, I can use division. Those are known as inverse operations. They have probably picked that up long before me, but I do stress it a lot in the 6th grade, using inverse operations to solve mathematics. So if I want to find out what x is here, I must go through the work process of using inverse operations to define what x is accurately, because that's what we're trying to do, consistently become accurate with our mathematical concepts. So in this case, I want to get x all by itself, and this is in any equation. If I have a variable, that is what this lovely thing is known as now, not just a letter in the alphabet, it's known as a variable once it's put in an equation or an expression in mathematics. If I have that in a algebraic equation, I need to get it by itself because that's what I want to solve. So for me to do that, I need to get rid of anything that's with x. And in this case, I'm adding 7 to x. Well, if I want to find out what x is, I first need to get rid of anything that is with x. And to do that, I'm not going to add 7. Instead, I'm going to take away 7 because that's an inverse operation that I can do, which will get rid of 7. If I have $7 and I go and spend $7, I now have no dollars. It's gone. But we know in mathematics, it is a balancing scale. Probably not the prettiest one I'm going to draw here. It's a balancing scale. So whatever I have over here, I have to have over here, because in mathematics, to keep us happy, we like things balanced. We just like to have the same here as we have over here. And maybe that's in life in general. If I have this, then I want this. And you want to keep it balanced. So if I do something then to one side of an equation, I must do it to the other side. So I took away 7 over here. I'm now going to take away 7 on this side. And then if all I have left over here is x, once I take away 7 from 15, I now have 8. I can then plug that back in, meaning put that back in, substitute 8 back in for x. And when I do that, 8 plus 7 should equal 15, and I'll know I'm correct. And I tell kids that all the time. Mathematics, although it seems like it's a struggle, you can definitely always check and make sure you're right. So all those times you're struggling or getting incorrect responses or incorrect solutions, you have the opportunity and the chance to go back and rework it to see if you can come up with a different solution that will make your problem correct. So in this case, I know I'm absolutely right. I should never get these wrong, because once I do the inverse operation, get what I want to know all by itself, then plug it back in and substitute it, I should be able to check and see if I'm right. And in this case, I am. Now, what your students will have trouble with, and I'll try to start shrinking this video down, I'll start seeing too if this thing will work. What your students will start having trouble with is when these problems become more difficult than just, hey, here's an adding and subtracting problem. What happens when they have a problem that involves, or an algebraic equation that involves multiplication or division? So the other day we had one in class, and it looked like this. 1/3 h equals 6. Now, some students will look at this, and I told them, and they will know automatically that 1/3 of something must be 6. There are kids cognitively who will see, oh, if I have 1/3 of something and you give me 6, how much do I have? How many things do I have to have in order to take 1/3 away from it? And so this is where kids get, especially with fractions, it gets a little difficult for them, because we're used to, how do I multiply and how do I divide fractions? And we have to remember what those things really mean. Well, if I'm multiplying fractions, it really is stating I have 1/3 of something, of being the multiplication process. So if I had 1/3 of a number and I got 6 back, what did I start off with? Now, some kids will easily see, well, 1/3, if it's 6, there's 6. That's 1/3. Well, then 2/3 must be another 6. And 3/3 must be another 6. So this is 1/3, this would be 2/3, and this would be 3/3, which gives me back a whole. So in this case, it said 1/3 of that was 6. Well, we discovered that 1/3 was 6. So the whole must have been 6 lines. I added another 6 lines and another 6 lines, which gave me a total of 18. So the only way a student can solve this is if they do something like this in mathematics, where they start experimenting with numbers in order to solve it. That's one way. And then they can make it anything they want, as long as it will meet the solution. If there's no solution, it just says 1/3 of h, they can do anything they want. But once they have this equal sign that states it's an equation and that it must equal 6, there's only 2 options they have. Try it for themselves. Figure out what it means, as in the sense of, if I have 6 and I know it's 1/3, what would be the next thirds? Or someone, in this case, must give me what h equals, and I have to say yay or nay to it. I have to say, yes, it's true, no, it's not. Yes, it's true, no, it's false. Yes, it's right, no, it's wrong. Because in mathematics, your students know, it doesn't matter. Eventually, there is a yes and a no in math. It's not like your favorite movie and your favorite book, and you wish you could change the line, or you wish you could change the way the movie ends. In math, 1/3 h equals 6 cannot be 2. And that's what the problem in the book states, that h equals 2. Well, if I said 1/3 times 2 equals 6, I would know that that's incorrect. And so in math, that's false. It's nay, it's no, it's not true. Because 1/3 of 2, try to give me 1/3 of 2 things, is not going to give me back 6. And then they'll have to work that process out of how did we add, subtract, multiply, and divide fractions, decimals, whole numbers. And we've went through all of that with them, or I've went through all of that with them. And they could do this here. They've got 1/3 times 2. They know they can put that over 1, and that's going to give them 2/3. And in no way is 2/3 equal to 6. So this would be, no, that is not equivalent, and a slash through the equal signs means not equivalent. So these are the things your students are working on, and they will get more difficult, but it's not that your students can't do it. They just need to stop and think about what it is that they're being asked to do in mathematics to solve that problem. Whoops. To solve that problem. We also did another one. This one, 9 equals 3/4 e. Again, if no one gave me the solution, if no one told me what e was, we would have to ask ourselves, could we, oops, I rewrote that. Oh, and here comes the dogs. That's Bruce. Max is out there somewhere. I knew they would make a cameo and the kids will want to see them. This is Bruce. Thank you. So this was another one that we did, and when you look at this, if no one tells you E is equal to something, they don't tell you what that is, then the students can go ahead and start figuring this out on their own. They can say 3/4 of E is 9. So whatever's over here, we know, of course, has to be bigger than 9, because 3/4 of it gave me 9. So whatever this number is here must be bigger than 9. Well, if 3/4 of something is 9, then that meant I got 9 back out of 3/4. So I would start looking at breaking up my 9 and thinking to myself, how could I have had something placed into 4 parts that where if I had 3 of them, it was 9? Well, 1, 2, 3, 1, 2, 3, 1, 2, 3, maybe 1, 2, 3 more. Because if I said that 3/4 was 9, there's 1/4, there's 2/4, there's 3/4, and if I have 3 more, that would be 4/4. So to me then, just looking at it even through a model, would state that 3/4 E and E must be equal to, according to what Mrs. P solved here, 12. Now I can plug that in and see if I'm right. I can go 9 is equal to 3/4 times 12. Well, we know in multiplying fractions, I put 12 over 1, and now I'm going to multiply it out. 9 is equal to 3 times 12 is 36. 4 times 1 is 4. That's an improper fraction that your students know. They know they must divide the denominator into the numerator to see what whole number I can get back. And in this case, I get back 9, and I know I am correct. Now, for your students, what we're going to be working on is a little tougher algebraic expression or an experience. I'm going to ask the kids to try to not model this out, but instead try to solve this using algebra. So if I look at this problem as an algebraic expression or an algebraic expression that turns into an algebraic equation, I need to say, what can I do to one side that I can also do to the other to solve for, yes, my letter, oh my goodness, my letter E. What can I do to solve for that E? Well, that isn't any better than the first time. I first have to ask myself, what is with the letter E? And in this case, 3/4 is with the letter E. Now we know that 3/4 by E is multiplying. So for us to get rid of what we're doing with E, it would mean we really need to divide. Well, I asked the students, how do we divide fractions? And now this is something we went over and they now have the knowledge about, is using the thing known as a reciprocal rule, which your kids will say keep, switch, flip. It's really known as the reciprocal rule, stating if I have a fraction and I flip that fraction to basically its inverse, instead of looking at 3/4, I'd flip it to 4/3 in division of fractions. I then can multiply those fractions together, and I get to do that because I then get to cancel out each part of the fraction. 3 will go into 3 once, 4 will go into 4 once. I now have 1 over 1, which is still just 1, and that means I'm left with 1 E on my right-hand side. Well, if I do this division of fractions to remedy myself of what's with my variable over here, I then must do it to the other side. So I must come over here and multiply 9 by 4 over 3. Again, I have a whole number. I want to turn it into a fraction, so I can multiply a fraction by a fraction. 4 times 9 is 36. 3 times 1 is 3. If I divide 36 by 3, I then end up getting 12. And that is what we said earlier, that E equal was 12 when I did the model. So those are just 2 different ways in which to solve these algebraic equations. Now, I think since it's 28 minutes and some odd seconds into this video, and hopefully I'll be able to say goodbye to you by 30, I'd love for your students to watch this. I'd love for them to practice the assignments, the practicing skills on page 425 and 431. And then we're going to talk about that tomorrow in Zoom, along with some review activities for them, so that we can keep moving along as 6th grade students. I thank you very much for your time. I can't wait to see the kids again tomorrow morning on Zoom. It's very exciting to get to see them. I love spending time with them. I hope you are all doing well. Stay safe and stay healthy. Until next time, blessings to you.